Okay, this question is a heat question where we have an electric kettle plugged into a 120 volt outlet. It will raise the temperature of the quantity of water from basically room temperature to the boiling point in the time given. An efficiency is provided for the process, and we are asked to find the resistance of the heating element and the current required by the kettle. Okay, so in the notes you are presented with this formula which says the efficiency of the heating process is equal to mc times the change in temperature divided by the electrical power times the time, all multiplied by 100%. Now, we wish to change the position in this formula of the efficiency and the power. And so if we do that, we can write that the power is equal to mc times the change in temperature divided by the efficiency times the time in seconds. And if we write the efficiency as a decimal, we can ignore the times 100% in that formula. Okay, so we have 2.5 liters of water. If 1 liter weighs 1 kilogram, then we have 2.5 kilograms of water. We will multiply that by the specific heat of water, which is 4,190 joules per kilogram times degrees C. And we multiply that by the change in temperature, which will be 75 degrees Celsius if the water changes from 25 degrees to 100 degrees C. Now, the efficiency of the process is 0.8, which represents 80%, and we will multiply that now by the time in seconds, which is 25 minutes multiplied by 60 seconds per minute, and that will give us a time in seconds. Now, in this equation, the unit of kilograms will cancel with the unit of kilograms. The unit of degrees C will cancel with degrees C, and the unit we're left with will be joules per seconds, which is defined as a watt. And so power in watts is what we would like to see for electrical power. Now, we have 2.5 multiplied by 4,190 multiplied by 75 in the numerator of this equation, and that gives us 785,625 joules divided by 0.8 times 25 times 60, or 1200 seconds. And if we do the division on that, we'll find that is 655 watts for the electrical power. Now, we want to find the current and the resistance of the heating element. So what I did was I said that from power equals current times voltage, we can find the current first. And if we do that, I is equal to P divided by V, and we have 655 watts divided by 120 volts. And that gives us a current of approximately 5.46 amps for I. Now, for the resistance, we can use Ohm's law, which says that I equals V divided by R. And if we solve that for resistance, resistance is equal to V divided by I, and we have 120 volts divided by 5.46 amps. And that gives us 22.0 ohms for the resistance. These are the two answers that we were asked for in the question. Now, of course, there's other ways to do this. Remember that if we wanted to find the resistance first, we could say that P equals V squared divided by R, which would suggest that R equals V squared over P, and we could use 120 volts R squared divided by the 655 5 watts, and I'm sure that if you do that out, that will give you about 22 ohms for the resistance as well, right? And so when we get to the electrical part of it, there's always more than one way to apply the equations that we have.